Hello students, welcome to today's class where we learn about how to start a design or how to do a design in terms of industrial and research approach. For that there are four pillars, that is first we have to select the forces or loading, then after we have to go for the material selections, after that we have to see whether these two are satisfying the safety methods or not, after that we have to come for the cost effectiveness. Next. What is force or loading? The force is what are the applied forces. The basically what we have learned in our previous semesters or in a school level, that was completely a static loading where a force is applied that is, and anti-force, that is a friction, is applied on that, and for which a mass as well as the mass or the weight applied from the body to the surface, for which we get an anti-gravity, or you can say the normal force. So this is what happens, we need to understand. This is what was the static force, static loading, because we are considering at a point or at an instance. That's why we say that it's a static load. That is only for applicable for a certain point. That is any static. Let me it has been static for a second, and we have calculated the mass applied as well as the force applied, x, y, z, everything. But this is not the main story. The main story comes with the dynamic loading, because dynamic loading we consider with compared to the whole geometry, as well as we considered with how much loading is applied from the external loading with respect to time, as well as the internal reflexes or the internal resistance with respect to time. So there are this is what we do in the dynamic loading. So dynamic loading is a practical scenario where loading is considered in a three patterns, that is repeated, reversed, as well as your irregular loading. So we consider the three main factors of loading, and we try to simulate the whole total things, what's going behind the scenes or actual things, because we have to, by dynamic loading only we can find out how much should be the usability age of a product. Next, after selection of loading, what type of loading you are giving and what loads you are getting in every points, so we can go for a material selection. There are two types of material selection. One is ductile and one is brittle. Now, how to select? If you need a material, with the tension capabilities or elasticity, you have to consider ductile materials. If you don't need elasticity, you need only a strength, you could go for brittle material. Now, how to consider? Let us take a simple example, a very simple example. If we consider the yield point of the ductile material over here and the yield point of the brittle material over here, as we know that there is not yield point of brittle material, but we could consider mathematically. So as we know that the loading should be below the yielding point, if we consider so, because we have to keep the loading beyond our maximum limit. So if you have the maximum limits of our loading, that is this point, that is the yielding point of the ductile material and yielding point of brittle material. Now, if I need an elasticity property on a material for a loading, then we'll go for the ductile material. And if I don't need an elasticity material of the body, then I'll go for the brittle material. Now let me come to another. This is the first preference. Second preference is if I need to select a material, but elasticity is not in the higher priority. If it is applicable to give, I will give. If it is not applicable to give, I will not give. The first one is what I have told you, that was completely for safety, but the second one is, it depends, now comes on the cost effectiveness. If it is very mandatory to apply for in terms of safety, then I'll go safety, then I have to select the first criteria. If it is not very mandatory for me to select for safety, that is, if I go for if I make some relaxation, then also there will be no problem, then I could do relaxation. For example, if it is not mandatory to have a elastic body, but the forces should be below this limitations, then either for brittle or ductile. So I could select brittle material without selecting the ductile material, or I could do the vice versa also. I could select the ductile material in terms in the place of brittle material. So everything depends on amount of forces, stresses what we are giving, and how much safety is priority over there. Is it mandatory to give or not? So this is entirely depends on this, as well as the cost effectiveness of the material also. But safety comes at the first. So what are the safety measures? There are three parallel lines, three lines of safety. That is, one is Gerber, as we know that this is the Gerber, and next one is the Goodman, and third one is the Soderberg line. So what do you mean by Soderberg line? These are the three lines of the safety. Soderberg line is states that, and if we could, in a nutshell way, if I could explain you, Soderberg line states that the maximum force can be applied in a body is still yield stress, and Goodman and Gerber states that the maximum forces I could apply in a body is until your ultimate stress. This is what the basics and basic of the, or you can say the nutshell or a one point method to understand the safety lines. We'll understand this about in the coming classes about what is stress amplitude, why it is very important for us, and what is mean stress, how to find the stress amplitude, and everything we'll learn, and what is SE. Let me give you one small idea what is SE. SE is the endurance stress, the maximum stress a body can take after certain period of time, or that period of till that period of time. That is called endurance stress. Next is the safety. How does it relates? So the Gerber line is the safety curve over here. Goodman line is the safety curve over here, and Soderberg line is works over here. That means the Soderberg line works. The maximum limit of Soderberg line validation is still the yield point, or over here for brittle material. But for the Gerber and Goodman, the maximum workability, maximum applicable stress is over here in this point. Okay, so that makes a problem, because Gerber and Goodman suggested a plastic mode or plastic area of the material. But does it is the safest place to work or not? I think no, because as we know, if it's in a plastic mode, in the plastic area or plastic zone, as every scientist, most of the journal says till now that this is better to eliminate the plastic zone, because plastic zone, if there is a maximum deformation, so you can't revive to the actual geometry, or you can't come to the back to the geometry what you need. So that means there will be there may be chances of structural failure also. So we try to keep the loading until our yield stress. That should be our motiveness. It should be until the yield stress, where we could have an elasticity, because if there is a changes or deformation in the body, it will revive to its own, back to its own shape and structures after the loading has been removed. So that's why Soderberg line is preferable more than the Gerber or Goodman line. Okay, next. So what should be the cost? So here comes the cost. The cost comes about the force or loading to be applied in the body. We have to see what are the forces or loading to be applied. Now this force or loading doesn't make so much problem on this, because the problem starts from here. If you have to compromise safety, then there will be you could earn a maximum profit, but the problems comes over here. You have to select a method of safety as well as material selection in such a way that it could fulfill the demands of force without any failure. Try to understand. I'm repeating it. You have to select the safety methods or the safety lines as well as material selection in such a way that it doesn't affect the loading or the forces, as well as there should not be any failure. That is, that total cost is equals to our ultimate cost of a design. That is a costing of a design. So this is how design is done. There sometimes we compromise something for which we get a catastrophic things. There you may see most time, many of the incidents, international incidents, happen due to the cost. People say thought about cost effectiveness rather than the safety. What happened? They have to pay for with their lives. So this is why cost is not so mandatory, and it shouldn't be mandatory. Yes, cost is also mandatory, because if it's mandatory in terms of pocket inch, do we have that amount of money to say, to buy or not? Does the industry have that amount of resources to buy or not? So you have to think about it and select in according to it, and the design should be in such a way that it should not be with maximum cost, but the most priority will be the safety, and the most safety safety will give you a better force handling, as well as minimum failure chances. That's why you have to think of safety, and as well as you have to select a material in a better way to avoid the failures of the structure or the methods.